Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to see what is exactly cross-validation and what are its different types. And we are going to discuss in detail about the cross-validation part, because once we move on to the hands-on, these are all the concepts which will come in very handy. And I have also discussed about cross-validation a bit in my previous video as well. And I do recommend watching my previous videos to make more sense of the existing video. So let's move ahead, and before moving ahead, I do recommend all of you to connect with me on LinkedIn and also on Instagram, and I will leave the link in the description box. So when we talk about the data set, right, whenever you are dealing with any ML algorithm, we have basically a training data set, we have test data set. This we have already discussed in the previous video, right? Your training data set accounts to around 70 to 80%, and then the remaining goes to your test data set. And then you have a validation data set that is derived out of your training data set itself. And this validation data set is actually used for hyperparameter tuning based on the cross validations. So now we are going to discuss this part in detail. Now when we talk about cross validations, right, now cross validation is nothing but the number of iterations that you want to take with the data set and then derive the best hyperparameter from it, the best value for your alpha, right? That is what is called as your cross validation. You are trying to do X number of iterations, which is equal to, let's say in this case, let's say you want to do 5 iterations, so your cross validation will be equal to 5. And let's say your training data set has 80 records. Now 80 divided by 5 comes as 16. Now 16 records will go in the validation set, and remaining 64 records will be used for training the model in one iteration. Now in this, there is a different way of selecting, there are different ways of selecting this validation set, right? That different ways is nothing but the different types of cross validations that we are going to talk about. Now there are the different types of cross validation is nothing but leave one out cross validation, hold out cross validation, KFold cross validation, stratified KFold cross validation for time series. Now let's discuss one by one. We will discuss leave one out cross validation. So when we talk about leave one out cross validation, right? So let's say your training set has 80 records. Now in this case, what will happen is you will pick up one record, right, for the validation set, and remaining 79 will be the part of your training set. Now like this, what you are going to do in the next iteration, you are going to leave the first record which you used as the validation set initially. You are going to use the second set. You are going to use the second record as your validation set. In the third iteration, you are going to use the third record. Likewise, you are going to reach till the end of 80 records. So like this, what will eventually happen is you have leave one out cross validation, right? You are taking one record, right, as your cross validation record, and rest all the records you are taking as the training set, right? And this iteration continues till the number of records you have, right, till how much ever your data is. Now this this is an old methodology, it's not used that much, but by the concept itself you will understand that okay, it is very time consuming, right? So you have to literally iterate through each of these records, and you have to make sure that your validation set includes each and every record, right? So automatically it becomes time consuming, and as well as it will cause overfitting situations by default, right? I hope you understand it because you have watched my previous videos as well. It will automatically cause your overfitting situations, right? Now similarly, there is another method which is called as hold out cross validation, right? In hold out cross validation, what do we do? If you have 80% records, if you have 80 records, 75% of the records you will mark them as a training record, and 25% will go in the validation, right? So this is the by the percentage, you are holding 75% in training, 25% in validation. This is called as hold out cross validation, and of course in this case as well you will have overfitting and as well as the underfitting situations, because there might be any outlier in the data set, right? So let's say if in your training data set one record is like a very huge record, right? So due to which the model will not get trained properly, so there might be an overfitting or underfitting situations due to outliers in the data set in case of hold out cross validation. Now the third one, and in fact it is The commonly used one, KFold Cross Validation, right? This is something that is used. Now this is similar to what I have explained in the previous video and even initially, right? If you have 80 records, you divide it by the number of iterations that you called as cross validation, let's say 5 in this case, you get the 16. So 16 records will be used in the validation data set and remaining 64 records will go to the training data set. Now since you have defined the CV value or the iteration value as 5, right? So now in this case you will have 5 iteration. In each of these 5 iteration, you are going to make sure that every 16 block of data is counted, right? So every 16 records is actually counted. So the first time the 16 records that you have chosen, right, the same 16 records are not chosen in the second iteration. In the second iteration, you are going to choose the next 16 records. In the third iteration, next 16 records. Now based on that, you are going to get your error, you are going to get your accuracy, you are going to average out the accuracy based on these errors, right? So this is called as your KFold Cross Validation. And when you talk about stratified KFold Cross Validation, right, in this case what happens is, now let's say, if your data set is something like you have 2 types of data set within your test data. Like if you have 2 types of data, 2 class of data within your test data set, let's say class A data and class B data, right? In that case, you define that, okay, in my each iteration, I am going to use 70% of class A and 30% of class B, or I am going to use 60% of class A and 40% of class B. I am going to use 50-50 of each. 50% of class A records and 50% of class B records. So that is called as your stratified KFold cross validation. Now in this case what happens is, even if you have any outliers in your data, if your, let's say, the output value is very huge compared to your input value, right, in that case as well this works well, right? It will nearly work very well. So that is why we use stratified KFold cross validation as well. It is used commonly. It is good for imbalanced data set as well, but of course it will not work for the time series data set. That is why we have time series cross validation as well. So if you see the first one, right, that we have discussed, you use a single test data set and then you iterate. Then you have your KFold as well. In the KFold, you can see this diagrammatically what is represented over here. We have already discussed it. And similarly, in case of stratified, it is same as KFold, just that we have defined the ratio, right? If you have 2 types of data, 2 class of data, in what ratio will they be present in each iteration in your test and in your trained data, right? So that is nothing but that is your in your training data as well as in your validation data. So that is what is called as your stratified KFold cross validation. Now once we do this in hands-on, you will be able to understand it even in more detail. Now similarly, you have something called as time series cross validation. So there might be some data set. So let's say the sale of one particular product each day, right? So each day is nothing but your data index over here, right? The time series cross validation. Now in this case, what happens is, as you proceed with the time, right, in this case you need to make sure your training data is captured. You cannot randomly choose your training data, right? Your training data has to be something like, okay, I want to use my training data from 2020 to 2022, right? And then my validation data I want to take from 2022 to 2023. So it has to go with the time in a single direction fashion, right? In a single fashion it has to go. It has to grow in a single direction. So that is what your time series cross validation talks about. It you cannot randomly choose your training and validation data set over here. Now if you see over here, right, the green part of it, right, now let's say you have the data only for 2020, right? In that case you will say that, okay, January to October I am going to use the data for my training and the rest October to December I am going to use for the validation. But now as the year passes, right, you are going to say that 2020 to 2021 December I am going to use my training data, and 2022 January to March I am going to use my validation data, right? So this is what your time series cross validation is all about. So I hope you like this particular video, you understood these concepts. So because the reason I am explaining this theory first is because when you move to the hands-on, right, hands-on is just 2 lines for this, right? It's just 2 lines. It's just writing 2 lines of code, when you are developing an algorithm. But understanding it is very important. So that is why I am taking this theoretical sessions first, so that when we move on to the hands-on, it really makes sense to you all. So I hope you like this video, and in case it is a bit complex to understand, since most of us come from the data background, maybe it won't be as easy. So in that case, I do recommend watching the video 1 time, 2 times, so that it becomes, you become used to especially these terminologies and you start understanding it in detail. So thank you so much for being till here, and do remember to like, share and subscribe to my channel.